Imagine surfing the web, visiting your favorite sites, completely unaware of a hidden danger lurking beneath the surface. A danger that could steal your information, hijack your accounts, or even control what you see on your screen. This is the world of cross-site scripting, or XSS, a web security vulnerability that can turn your trusted online experience into a hacker's playground. In today's digital world, where we trust countless websites with our personal information, security threats are ever present. According to Open Web Application Security Project, or OWASP, XSS consistently ranks among the top 10 most critical web application security risks. This means millions of websites are potentially vulnerable, putting your data and online experiences at risk. In this video, we will talk about XSS vulnerabilities and how to exploit them. Since you clicked on this video, I'm assuming you are interested in security. If you are an aspiring ethical hacker or new to bug bounty hunting, hopefully at the end of this video, you will know how XSS vulnerability actually works, how many types there are, and how you could exploit them. And if you are a normal user, hopefully it will shed some light on how hackers can actually steal your data using XSS. XSS stands for cross-site scripting. It is a client-side vulnerability that enables attackers to manipulate a vulnerable website so that it returns malicious JavaScripts to users. In my opinion, XSS should have been called JavaScript injection, but we will come to that later. Let's understand how XSS works. When you open a website on your browser, the browser sends a request to the server and you get a response that's displayed on your browser, rendered with the help of HTML, CSS, and JavaScript. As a user, you can manipulate all these. Let me quickly show you how. For example, let's say I visit google.com. If I click on view page source, you can see it has an HTML, some JavaScripts embedded, and some CSS. What I can easily do is I could manipulate this. For example, let's take this. Instead of Google search, I could write Nigam Elastic. And instead of I'm feeling lucky, I can add here I'm bored. So you can see I actually manipulated the HTML on my own client, aka my browser. That doesn't mean everyone who visits google.com would see these two buttons. I can simply go to google.com and you can see here I see Google search and I'm feeling lucky. So you can manipulate the HTML, CSS, and JavaScript in your own browser client. But what if a malicious user sends a payload to the server so that when the victim visits the website, this script is injected on victim's browser and sends all the sensitive information to the hacker? Now, of course, this is an oversimplification of a very specific type of XSS, but in a nutshell, that's how XSS work. So you might be asking, where does this lie on the OWASP top 10? It comes under A03 or the injection category. The CWE for this vulnerability is 79, which is improper neutralization of input during web page generation. So if it's under the injection category of OWASP top 10, why is it not called JavaScript injection instead of cross-site scripting? In order to understand that, you need to know the concept of same origin policy. You see, security on the web depends on a variety of mechanisms, including an underlying concept of trust known as the same origin policy. This states that if content from one site is granted permission to access resources on a web browser, then content from any URL with the same protocol, in this case it's HTTPS, hostname, which in this case is example1.com, and port number, which in this case is 8080, will share these permissions. Content from URLs where any of these three attributes are different will have to be granted permissions separately. So when the attacker is able to inject this malicious JavaScript, it is essentially bypassing the same origin policy, as the attacker's code is not coming from the website that you trust but from a different origin or site, hence the name cross-site scripting. Now, even though this vulnerability was being exploited since 90s, Microsoft security engineers came up with this term in January of 2000. Great, since now we know the origins of cross-site scripting, let's talk about its market share. XSS is the most widely attacked and reported vulnerability. While there is no real-world data that tells us the number of XSS vulnerability out in the wild, the closest we could get is from this HackerOne dashboard. As you can clearly see, CWE79, which is the parent common weakness enumeration for cross-site scripting, has the highest number of reports. And if you think about it, the reason for such a high number is quite simple. No matter what your backend might be, your website would still be rendered on a web browser, and the chances of missing something are quite high due to the ever-increasing complexity of modern web applications. So let's talk about different types of cross-site scripting. We have reflected cross-site scripting, stored cross-site scripting, and the last one, DOM-based cross-site scripting. Reflected cross-site scripting arises when an application receives data in an HTTP request and includes that data within the immediate response in an unsafe way. Let me show you how. So here we have a wonderful blog thanks to Web Security Academy. I'll give you the link to Portsfigur's Web Security Academy in the description. And on this website, let's say I want to search something. Let's say I search hi. And you can see there are 5 matches for this hi post. If you look closely here, I am actually putting hi here, and that's how it's being searched and it's reflected here. But what if instead of searching this, I put a HTML tag? My favorite HTML tag is marquee. If you don't know what marquee tag does, it simply makes your HTML element move, as you can see in the example here. Since I know this hi is reflected here, let me add this marquee tag and let me put negam elastic and close the tag. And now if I search it, we can see the HTML tag moving. So this means we are able to inject HTML. So why not try to use the script tag? So let me put script alert and put negam elastic, and it should be a string. So let me make it a string. And click on search. And now you could see we have a pop-up that is actually showing us an alert. And this means we could inject JavaScript on this website. Like I said earlier, if you can inject JavaScript, you can basically bypass the same origin policy and make it do other stuff. For example, I could write script alert and write this: we are facing some technical difficulties. Please check attacker.com and end script tag. And now if I click on search, this is the message that I get. I can simply copy this and open it in a new tab or new browser altogether. And if I paste this or send it as a phishing attack, as soon as the user clicks on it, it will see this message. This would be very effective for a phishing attack because I could clearly see that the message is coming from the correct website. So even though I trust this website, I could be easily fooled into doing some other things. And this is a very basic scenario, but since I have access to add HTML and JavaScript tags, I could actually host my attacker's website and then pull into images, fake logins, maybe do redirection, and a lot of other very malicious stuff. Let's have a look at a real-world example. In 2018, a hacker actually made the official Vatican News site to declare God is an onion. And in this case, it was not very malicious, it was done more for fun. But you get the picture. Reflected cross-site scriptings are very real and can be used to perform malicious activities. The next one on the list is stored cross-site scripting. In reflected cross-site scripting, our inputs were simply being rendered in the response. Hence, the impact was only limited to our maliciously crafted URL. But what if our inputs are stored in a database? In this case, the impact would be really high because everyone visiting the vulnerable website can be affected. Let me show you how. So again, we have a website here. Again, a blog. I could view the post. You can see the post here. And I could leave a comment here. So again, like last time, let's put a marquee tag here. Let's put the name, email, and website. It says thank you for submitting. We can go back to the blog, and as you can see, the marquee tag is actually working. But this time, it's coming from the database, meaning this post ID 9, I can copy and paste it anywhere and I would still be able to see this. This means anyone who visits this post, not crafted by me, by simply navigating. So let me show you how. I go to the home page and click on view post again. And I could still see this, which is different from a reflected one, because these values are actually stored in the database. Now, since we established that in a stored XSS, the data is actually stored in the database, I can simply put my payload. Let me make it. This is not the correct website. Please go to attacker.com and end the script tag. This would be shared with everyone who visits this specific page and not just by a maliciously crafted URL. Let's see it in action. Let's go back to home. Let's click on view post. And now you can see this is not the correct website. Please go to attacker.com. This makes stored XSS even more dangerous because unlike a reflected XSS, these are stored in the database and can be viewed by everyone who visits the specific page where the database entries are being rendered. So now we know why this is a bit more dangerous than the normal reflected XSS in using phishing attack, but let me show you how it could be way more dangerous than just a simple phishing.
Great, so we have here another blog, and as you can see, we see a bit more options here. We have home and my account. Earlier we just saw home button. Let's click on my account and it has a login page that requires username and password. Going back, if we go to an individual post, we could see just like previously, anyone could comment here. Quickly checking if HTML injection works. So again, marquee. Quickly adding the details. Going back to the blog, and marquee works, it's a stored XSS. But here, since this has a login page, we can steal cookies. If I put an XSS payload on this post in such a way that I could grab all the cookies using JavaScript, a logged in user, as soon as it visits this page, would get that JavaScript injected in its session. And it would be similar to the diagram that we saw in the beginning, where we would be able to grab sensitive information, in this case cookies, from the target to the attacker. Now you can go here, go to inspect, go to storage and check the cookies. But I use this very handy extension called the cookie editor. And you can see right now, unlogged in user, we have a cookie named session with some values. So let's try to steal cookies and become the admin. We already know that we could inject JavaScript. So let's try the script. Tags. And now in between this, we'll write our JavaScript code that will steal the cookies and send it to our server. So I will write a simple JavaScript code that could do that. So first things first, let me do an XHR request that you can do like this. Creating a new XML HTTP request. Then we do xhr.open. And now we'll add the data in the post method. So post. And here would be our server location. So HTTPS and attacker server. And it takes another argument, which is true. XHR or XML HTTP request is a pretty simple method. You can find out more about it by simply searching it. And apart from XML HTTP request, there are also other methods that you could use like fetch and know all about it. going back, I will set request header to be text plain because we'll just send normal text content as cookies. And finally, we will send the cookie, which will be document.cookie. So those 4 lines of code would help us steal the cookies of the user who will visit this post. Now, ideally, you would create your own attacker server that will just listen and get all the post requests. But of course, we do not want to spend so much time creating such a server. And I quickly added double quotes here because I realized I forgot. So for this attacker server, there are various free and paid tools available that you can use directly and grab the cookies. Since this is a Portswigger's Web Security Academy, I will use Burp Collaborator to do this. If you want to know more about these other Burp Suite Collaborator alternatives which are free, I have already made a video about it that you can view by clicking the link, and I will also add it in the description. So let me quickly open my Burp Collaborator, and now I have my Burp Collaborator server pulling things. I will copy the Burp Collaborator server URL to the clipboard, and now I can simply paste it here. I will add the values again, and post a comment. Now let's go back and let's wait till we see if someone actually visits the post and if we get some data. Let me click on poll now to check if someone actually visits it. And right now no one has visited it. So if I go back to the blog, I see nothing is happening. So let's quickly check the HTML context. And I probably might have made some mistake because I don't see anything here and I don't see the tags either. So let me make sure I didn't miss anything. Let me quickly copy this, add a script tag, paste it, paste the code, and then end the script tag, add the name, email address, website, post comment, go back to Burp Suite Pro, and here we got some data back. We have DNS lookup, which is four of them are DNS lookup. If I go to the 5th one, which is an HTTP request, which we actually sent, let's see what requests we got. And we have a secret value and a session value. Let's add these two to the website. So let me open this, use my awesome cookie editor extension. We already have a session, so I'll go back, copy the session name, and click on save, add a new cookie value, which will be secret, and the value of secret would be this. Let's go back, secret value, save, and now we have both. I'll go to the home page, and now if I click on my account, you can see I'm the administrator. So essentially, with our payload, we were able to steal the cookies of the user who visited the page. In our case, the user was administrator, we hit the jackpot, and we did an account takeover. Now we can update an email and do whatever we want as a malicious actor. A real-world example of stored XSS was Twitter's TweetDeck vulnerability that occurred in 2014. The stored XSS vulnerability was exploited by hackers, and the report cited that people's TweetDeck accounts were hijacked. This was a very powerful incident, as a high number of customers' accounts were compromised.
Moving on, we have the third and final type of XSS called the DOM-based XSS. DOM-based XSS is an XSS attack wherein the attack payload is executed as a result of modifying the DOM environment in the victim's browser used by the original client-side script. So basically, the client-side code runs in an unexpected manner, causing the cross-site scripting.
Let me quickly show you how. So here again we have a website. Let me search something here, and you see 5 search results for hi. If I search Elastic, there are 0 searches. If I inspect it and search for this keyword, you see I have 2 matches. This is the first one that we see right here. And if I go to the next one, it shows the search term. If we try to compare it to our previous reflected XSS lab, which had only one rendering, we could clearly see that this one is similar to that. However, here we have a new one where the source of the image, which is a GIF, is also rendering our search term. Now let's try the very simple marquee text. And if I go here, write marquee, elastic, marquee, and search, you see the whole tag is being rendered and there is no HTML injection. Let's search for elastic again. We find this search result and we find this search term again. If we check which one is being rendered, you simply go and inspect and you see, just like the reflected one, is rendering the first one. This means the developer of this website added proper sanitization and we were not able to inject our payload successfully. However, if we go to the next one, we could see this image source is being loaded on the DOM or the document object model, which is the HTML page, and it is doing some other stuff. So let's copy this. And let me simply paste it here. And now you could see whatever we are adding is being rendered directly. Let's remove this, for instance. And now we see the original HTML node. But what if I do this and then add a script tag here and then another script tag, and of course made it as an alert. Essentially now what we are doing is by adding data from here till here, we are creating a new script node after essentially closing the image source tag. Now, of course, there is a quotation and ending of a tag here, but we know in HTML you can add random tags. So we can use this payload to bypass this filtering. Also here, even though developers sanitized the main response and stopped the execution of a reflected cross-site scripting, we were still able to modify the DOM, and hopefully this will render correctly and show us the alert message. So let's try this. Like I mentioned earlier, these are the things that we added in order to inject a script tag. Let me delete all this, paste our payload and click on search. And now as you can see, we modified the DOM and we're able to execute a DOM-based cross-site scripting attack. Let's quickly search. This is our initial reflection. And checking the next one, which is the DOM, you can clearly see our payload worked. The HTML tags of image started here, ended here, and then we were able to add a script tag. The main thing here to note is, unlike reflective cross-site scripting, the developer actually fixed the issue. However, since there was some other node which was rendering users' input, we were able to bypass, or I should say close the tags and we're able to inject our own script tag. DOM-based XSS is often overlooked and are a great way to find bugs, especially for bug bounties. A real-world example of a DOM-based XSS is the CVE 2022-25069, which is a fairly recent vulnerability where a DOM-based XSS was allowing attackers to perform remote code execution. Of course, since it gives you remote code execution rights, the CVSS score is 9.6 and the vulnerability is critical.
So now we know all three types of XSS, but how should we prevent this XSS from occurring on your website? First of all, at any point where there is a user input, be it a text field or a search field or even passwords, filter as strictly as possible based on what is expected or valid input. For example, if you have a field that takes input of phone number, make sure you can prevent that specific field from being exploited by XSS by simply preventing special characters like hash, greater than, smaller than, etc. Then, wherever the user controllable data is shown in the HTTP responses, make sure you encode it. To the third point, modern browsers can interpret the responses in the way you intended by checking response headers. Make sure you use the right content type and X content type option headers to prevent XSS. And lastly, use content security policy so that even if your website is vulnerable, the content security policy can minimize the impact and contain the blast radius of an actual exploit. OWASP has a great XSS prevention cheat sheet that you should definitely use while developing your software that could greatly help you in preventing XSS vulnerabilities. I will also add link to the XSS prevention cheat sheet in the description.
Now, before we conclude this video, I would like to show you one more trick that you could use as an attacker while doing bug bounties. Simply type JS. And I know the name sounds a bit offensive, but believe me, this is very interesting. JS is an historic and educational programming style based on atomic parts of JavaScript. It actually uses only 6 different characters. So how does this help you? Imagine if a developer is smart enough to block all the different special characters but leaves these 6 in its blacklist, then what we can simply do is that we could inject JavaScript by just using these 6. Let me show you how. So ideally, if you put alert 1, it should show you alert, and you can use this to simply create a payload. Now let me quickly show you by copying this. You can go to inspect element, go to console, paste this, and then as soon as you'll press enter, you can see that it actually worked.
I know this video has been too long, but we barely touched the surface of all things XSS. This video has been really long in the making, and I hope you guys enjoyed it and got some useful information out of it. In case you have any doubts, please feel free to ask them in comments, and I'll try my best to answer you as soon as I can. Thanks for watching and have a good one.